All right, it's 4 o'clock. It's time for lightning talks again. Thank you. Thank you. How was the rest of EuroPython for you today? Was it good? All right, thanks. I think all the people with the green shirts, everybody who's putting work into this, really appreciate that you like it. Okay, let's get started. We don't have two setups again. We're going to stick with a quick switch over. So if you are giving a lightning talk today, please be prepared to quickly set up. We're going to start with Anton Turin about elliptics. And the person after that is going to be Austin Bingham on being super. Austin, are you there? Excellent. Best position you could pick.
We see it there if it shows up. We see it on that screen.
There's a preview down there. Yeah.
Okay. So.
All right, let's go.
Hello, my name is Anton. I work at Yandex. Sorry. Okay. Yandex is a Russian company. We provide services like searching and something wrong. Search, mail, video, music, and so on. We have a lot of user-generated content services. And today I would like to introduce you one of our open source projects named Elliptics. Elliptics is a distributed fault-tolerant key-value storage with high availability, high scalability, and a lot of other buzzwords. We use it in our production to store petabytes of data and billions of keys, and it works perfectly. It was founded to solve problem when one of our data centers goes down. Idea of Amazon Dynamo is in base of this storage. Of course, Elliptics has DHT and provides replication by using mechanism of elliptics groups. Each node in one group takes responsibility for some range, bless you, for some range of keys and this DHT ring. And when you store your data by key, hash is calculated from this key, and according to that number, data is transferred for some node. If you need replication, you should write your data in 3 different groups, for example, in 3 different data centers. Elliptics is not simply storage. It provides a distributed cache, Russian words imagine, and we use it in our, for example, content delivery network. We use this cache, for example, in engines. We use this cache in services which are related with some operations with sending files, for example, photos. If some photo becomes very popular, we could copy this photo to the cache, closer to the user, so we could save a lot of I/O and network. The other feature is that Elliptics provides you an ability to start your own program on the same node when your data is stored. It's server-side scripting. You could write your own program on Python, C++, and many other programs, languages, sorry, and you have a guarantee that your worker would launch on the proper node and you need not copy any data through network. Elliptics is easy to use and easy to enlarge. It has a rich and powerful Python API. It supports asynchronous operations, so you could implement a really good scalable applications using it. Of course, we provide C++ and Go API, and we have, of course, HTTP interface for our storage. It has buckets and keys like S3 interface, sorry, and it's not compatible, but full S3 compatible interface is being developed now. Oh, sorry. It's quite obvious that it's impossible to store billions of keys on ordinary file system, for example, on Ext and X3 and so on. So we implemented our own backend for elliptic storage. It's named eBlob. At the first glance, it looks like a simple large binary object, and you just append that data to the end of this file and marked deleted keys as deleted. But there is a lot of rocket science in this part of elliptics, and it's extremely fast. So the bottom line is if you need distributed storage in your own project and you could not rely on S3 because of Big Brother or something like this, I think I'm pretty sure that elliptics is a good choice for you. Thank you.
Thank you, Anton.
Hopefully this just works.
So the next one is Austin on being super, and Mikko Atama is the next one. Mikko, are you there?
First.
Okay. If it works, that is the big.
I can't see you, Mikko.
There we go. Okay.
There you are. Thank you.
Great. Hi, my name is Austin Bingham. I work for and part own a small software company in Norway called 60 North, and I want to talk about, well, on being super. So, who here uses super? Just raise your hand. So nearly everybody. That sounds about right. Who knows how super actually works? Much smaller hand. Who knows about the super proxy objects and method resolution order and the C3 algorithm? Okay, all right, so basically a lot of us use super, but don't really understand exactly what's going on inside of it. And that's the position I was in a couple months ago when I had to develop some training for somebody, and I wanted to know, how does super work? I used it for literally more than 10 years, knowing that super is how I accessed the base class implementation. That was my model of it. I'd never had to really get any fancier than that. But as I looked into it, I learned that actually super is really fascinating, and it opens a door to a wide variety of really interesting design choices. And so I thought it would be a great topic for something like a 5-minute lightning talk format. So here I am. So the first thing you need to understand super is method resolution order, which a lot of you probably know already because you use method resolution order all the time implicitly, even without super. All it is an ordering of an inheritance graph. And so here I've created A, B, C, and D, a standard diamond, well maybe not standard, maybe not a good idea, but it's a diamond inheritance graph. And you can see the MRO for D in the end there is D, B, C, A, and object, because of course object is always in there. So it's just an order that Python has come up with for all of the classes in an inheritance graph. As I said, this is useful. This is used for all method resolution. So you call d.foo, then the method resolution order is used by Python to figure out which of these objects, which of these classes, implements foo. And the first one that has foo is the one that gets used. That's fundamentally what MRO is. So how is MRO calculated? It can't just be randomly chosen. It must have some order. That's what the C3 algorithm is, or C3 linearization is the computer sciencey term. This came out of the Dylan language, I think, I don't know, many, many years ago. And now it's used in Python, Perl, Dylan, probably some other languages. It's very popular for dynamic MRO calculation. It has 3 basic things that it guarantees when it calculates the MRO. One is that derived classes will come in the MRO before their base classes. So it guarantees that. It guarantees that whatever base class order you give in your class definition is also preserved. So the relative ordering is always preserved based on what you tell it lexically. And finally, the first 2 constraints are conserved anywhere in an inheritance graph. So the relative ordering of classes is always the same no matter where you start. These are the rules that C3 provides, and that's how Python resolves functions, methods, I should say. C3 brings with it a little bit of baggage. One of the interesting side effects is that not all inheritance graphs are legal. So in this case, you see I've created another inheritance graph where D inherits from B, A, and C in that order. And because of the guarantees that C3 wants to make, or is going to make, it's telling you it can't do that. It can't have A before C because A has to come after C because A is A. Is that a bell I should be concerned about? Okay. I don't know what's going on with it. Really, I don't. So you can get yourself into a hole. You may have seen this, maybe not. I'd never seen it, but I thought it was interesting. So that's C3. So finally, we come to super. What is super actually doing? And this is the most pithy, terse explanation I can come up with. That's not a poem, which may have been a good idea. But given a method resolution order, some MRO, calculated by C3, and a class C in that MRO somewhere, super gives you an object which will resolve method calls using everything after C in that MRO. That is the definition of what super does. Does it make sense? Yeah, you read it a few times later if you want. When you call super, what you're actually doing is creating a proxy object, a super proxy, and that's the workhorse of super. That's the thing that embeds all this logic about looking in the MRO in the right place and using the tail and so forth. So I had this nice picture of, not really horses, it's a horse and a donkey. One of them is named Mr. Sir Henry, which I thought was a cool name for a donkey, so I put it up there. They're the workhorses of super. Super proxies are, like I said, just regular objects. You can take a reference to it, you can interrogate its type, and you can see that it has a little dunder thing in it called this class, which is the class type you passed as the first argument. So you can examine super a little bit and get a better sense of kind of how it's put together and what it's doing. So, in summary, I think I'm well in time here. One, Python calculates an MRO for all classes. You might have known that already. C3 is the algorithm that does that. Super requires an MRO and a starting point in that MRO. That's how it knows what to trim off of the MRO. And finally, super proxies find the first class in the rest of the MRO that supports the function that you want to call, or you tried to call, and that's how super works. Thank you.
The next one after Mikko will be Dmitry Milajev. I hope I pronounced that arbitrarily wrong. There you are. I can see you. Thank you. Also, would somebody mind to share what the ring was about? Is that a nice message, or? Please, turn off your phones. We all will be happy with that.
Hello, Berlin. So, who is having fun in EuroPython? Please raise your hands.
What's that it?
Again. Very good. My name is Mikko, and where I'm coming from, you are going to have more fun. So we are going to have a PyCon Finland, and I'm here to tell you why you should go there. First of all, we are having fun now, so let's compare Finland to Berlin. So, first of all, we are a little bit smaller community there, so we are still maturing, so we need a lot of guys to come to see us and to tell us that the Python is good. I'm especially proud of our little PyLadies community, which started like 1 year ago with 2 members, and now we have 60 members there. And then, of course, in Finland, it's not the Berlin, so you can use your laptop for the purpose it was created, which is warming up your labs. Also, a lot of cool technology comes from Finland. So, if you like Linux, SHA, or IRC, you should come to pay us a visit. Looking for a freedom. And we are the only PyCon in the world where we have a sauna party. And I need to tell the truth that I'm not actually one of the organizers. And because I'm not the organizer, I can't make any promises. So if there is no sauna party, you are invited to my home. I have a sauna for 3 people. And what I hope that you would do now that you go to fi.pycon.org, and what we lack in Finland is good speakers. So we have had problems to have these foreign superstars come to our conference. So if you have a talk in PyCon, please reuse that talk and come to tell the talk again in our PyCon in Finland. Thank you.
Lynn, are you around? I can see you here next.
It will show up there first. If he gets it working. It works.
Okay, cool. Okay, my name is Dmitry Smilaevs. I'm a PhD student at Queen Mary University of London, and I'm doing computational linguistics 24 hours, 7 days a week. So this talk will be about distributional semantics. Semantics as a study is all about meaning, and because I'm doing languages, so it's meaning of sentences and meaning of words. And like the main ideas of the whole field can be said in these two sentences. So you should know a word by the company it keeps, or a little bit more formally, that semantically similar words tend to appear in similar contexts. So if you think about it, then you will see words like beer or wine occurring together with, I don't know, bar and parties. And probably such words as Python will occur with some different words, like, right? So, oh, sorry. This IPython is a bit confusing. So now we can, if we get a big text, we can just look to it, and for every word we will look, what are the other words our word of co-occurs together? So for the boy, we will know, okay, we see it with A one time, and we see it with might one time, and so on and so forth. And then we do it on many other sentences, and do our counting, and we get something like this. So we got our boy, and we know that it was together with time about 100 times, and together with year about 102 times. And then we do the same with girl, and what we notice that these numbers kind of similar-ish, right? At least they're not, the pattern is different than to notion and idea, right? So we can measure a way of similarity. So how can we do the similarity thing? What we're going to do is that we will see these words as vectors in a multidimensional space. And vectors, these are just some directions to points. And between 2 points, you can calculate the distance. Or you can calculate the cosine between these 2 points, right? So that's what we are going to do. So we'll use scikit-learn and ask us, okay, given these vectors, please calculate us the distance. And what we see that indeed, boy is much closer to girl than to notion. And we would expect it. So can we go even further? Can we actually make it visible to us? So now our vectors, they're kind of in a so huge multidimensional space that we cannot even imagine how it looks like. So what this code is doing, that it tries to get the same points on a 2-dimensional space and tries to preserve the distances. So why it's 2 dimensions? Because then we can easily plot it. So, and if we plot, we get something like this. And so here you see that boy is close to the girl, mother is close to father, and all the family words, they cluster nicely in our field. And then kind of business-related words are here, and colors are there, and so on and so forth. So that's what distributional semantics is about. Though my main message is this. Oh, sorry, is this. So it was really few lines of code, but there were some intuition behind, so some science was behind. And if scientists tell you, they kind of know what to do, but developers know how to do things. And if you connect these two things together, you can achieve very great results. And it doesn't really apply to linguistics, it applies to any science. And I really encourage you to look for some cool scientific results if you're a programmer, or learn programming if you're a scientist. Thank you.
The next after Lynn will be Harut Dagesyan. All right.
Oh, awesome. My turn. Okay. Hold on. I don't have slide notes, but I can kind of makeshift. Hold on. Oh, damn it. It's not set up right. Totally unprepared. Okay, so first a little bit about me. I am Lynn Root. I actually live in San Francisco. I am a back-end developer for Spotify. I am also leader/founder of the PyLadies of San Francisco and a board member on the Python Software Foundation. So earlier, Mikko from PyCon Finland talked about them having PyLadies for about a year now, which is pretty awesome. Side note, you should all go to PyCon Finland. I spoke there last time. It was awesome. And you might be wondering what exactly is PyLadies. So PyLadies is sort of a mentorship group for women and friends in the Python/open source community. We're there to support women and diversity. We've been around since the fall of 2011, and PyLadies San Francisco started in April 2012, and we're now up to like, I don't know, 1,800 members. And we have about 50 locations all around the world, except Antarctica, which is kind of the purpose of this talk. Maybe we can get a little PyLadies in Antarctica, little penguin PyLadies. Why would you want to start a PyLadies? I'm presenting about PyLadies. Why would you want that? It essentially is the motivation for you to learn or to better your Python knowledge. I started PyLadies by wanting to learn how to code in Python and got some friends with me, and it kind of blossomed from there. It also gives you leadership and organization, and it creates sort of a networking kind of web for you, so you can kind of find jobs or build your resume. And also, we kind of want to take over the world, so that's kind of awesome. How can you get PyLadies? You can pip install it. I created a Python package right before PyCon, and it's up on PyPI. So you can go grab it. Yeah, there's literally a PyLadies on PyPI. So many people ask me about that. Yes, there's literally, not figuratively, literally a Python package. So pip install PyLadies, and then run PyLadies handbook. And what it does, what it gives you, is it's a handbook and a checklist on how to start your own local chapter. And it has some assets and images so you can promote PyLadies. Some workshop materials so you don't have to create your own workshop. A lot of them are beginner workshops. And I am still developing it, and we'll have more scripts and stuff for local organizers to work with Twitter and Meetup and data mining about our Meetup statistics. So if you don't want to pip install it, you can also go to kit.pyladies.com to see what it's about. Let's just read the docs. And basically, I wanted everyone to be able to have their own PyLadies. Thank you.
And the next one would be Radomir Dopieralski. Radomir, are you here? All right, thank you.
It's okay?
I don't know. There's the screen on there. It should be, I think it's coming up now. It's there.
So, okay. If I try.
Okay.
Oh, it's. Sorry. I think it should be
I can't help with Russian.
cloned. Okay, I just
Can you move it over there and there say, do you see that screen over there? There's another screen down there, maybe you can use that for the
I just will move the presentation there and show this way. Okay. My name is Harut. I want to present our forms like Django or WT forms, but ours forms purpose to validate user input, convert that input from form representation to Python internal representation, render the forms, and our key feature is that they work well with nested data. So we have a little bit different abstraction layers. The main object is form. It contains nested structure of fields. Field represent a single atomic, maybe atomic or maybe complex structure of data. Every field has a converter, has widget, has permissions, and has data before converting and after converting. So here is the form. To create your own form, you should subclass form class and define a list of fields. Here you can see there are nested fields, and to use form, you instantiate it with initial data, then call accept with data you want to convert, and either get a data in form.python data or get errors. Here you see a result of conversion of nested structure. So converter is an object with two main methods. One is toPython, which accepts a Unicode string and returns object of type of whatever type you want. And the second method does reverse conversion. And you can define validating functions that just validate or do simple one-side conversions. So, and from these methods, you can throw validation error, which is written in form.errors. So you put converter in the field and validators as arguments to converters. Converters can be required or not required. There is implementation of multi-dict features that allows us to add values under the same name, list of converter with nested converter. Here you see implementation of multiple selects by list of converter. You can easily tweak converters by copying them by call. And here is an example of implementation of a little bit complex converter that converts, not implementation, usage, that converts SQL, that converts dictionary to SQL alchemy object. So widgets are a little bit simpler. They just take a field and render them to the template. You can render the entire form or a single field. And where do we use? It is our CMS with some keywords presented. So here it is.
Lars Butler, are you there? Is it you?
Hello, everybody. My name is Radomir Dopieralski. there is a saying that Python is going either to save the world or destroy it. And I think there are enough people working on the saving part, so I thought I will work a little bit on the destroying part. So this is a hobby project of mine. It's a killer robot that's going to run around and kill everybody. It's made with a Raspberry Pi inside and programmed in Python, obviously. It started as actually as a Meccano set thing with some Arduino attached to it, but that didn't work too well. So I got a servo controller for it, and it's a programmable kind. So I thought, oh great, I can program it. It came with some language based loosely on Fortran. I don't know if you know Fortran. It wasn't as easy to program as I anticipated. Then I decided to upgrade the robot and give it another knee, so it has 3 degrees of freedom per leg. And thanks to that, I can make it move much smoother, and I can make it tilt and do all sorts of cool acrobatics. But because of that, I had to do something called inverse kinematics, which involves a little bit of math, mostly trigonometrics, and a little bit of linear algebra. And doing that in anything but Python was too painful for me, so I decided to remake it again and put a Raspberry Pi inside. And also to put a bigger battery, because all these extra servos were too much for the 3 AAA batteries that I had in there. And it's growing, it's still growing. Right now it has a gyro sensor, so it can sense when you tilt it or when you pick it up or things like that. It has an audio, it has a speaker connected to it, so it can talk, for example, the voices of turrets from Portal. Very useful, like, hello friend, I'm going to kill you. And it's coming on nicely. Unfortunately, I was planning on bringing it here and showing how it works, but unfortunately, just before the conference, it burned 3 servos in the legs. So I decided, no, I'm not going to risk that. But this is how it looked like recently. And that's all. Thank you. Oh, by the way, it's called Kubik, so you can Google that and see it.
We are making very good progress. Everybody who's in the overflow slots has a very good chance to actually get their talks in here. Dmitry Semerov, are you around? Excellent, get ready.
Works. Hi, everybody. So I got to practice this elevator pitch when I was at the OpenStack Summit in Atlanta a few weeks ago. So I've condensed that all for you to just a couple bullet points. So here we go. This is ZeroVM, and I work for Rackspace, by the way. ZeroVM is not ZeroMQ. It's not Docker. I can't tell you how many people ask me, is that like Docker, after I explained it to them in a few sentences? So it's not Docker. Docker's cool, but this is not Docker. It is not a drop-in replacement for any other type of virtual machine. It's something completely different. It's not NACL, but it's based on it. And if you want to know about NACL, I'm not going to explain that to you. Just go read about it. It's pretty cool. It's open source, and Rackspace is sponsoring it, but that doesn't mean it's a Rackspace thing. Anyone who wants to get involved in it can. Just to give you a quick comparison of different types of virtualization technologies, something like KVM would be in the far left column. There's no kernel, there's no operating system, the overhead is extremely low, there's no interpretation, it starts up in about 5 milliseconds. And it's extremely secure, but of course there are some limitations. A couple other key aspects. There's no place to get entropy from. Time and random functions behave completely deterministically, so it's just like a pure function. If you give it X for input, you will always get Y for outputs, no matter what. And there's no persistent state, so you can't really write a daemon with this thing. It's more of like don't think of it so much like a program, but think of it as like a function. Your programs behave like functions, so you decompose your application to small, tiny little programs. So of course you need to do something with this. So for I/O you have to map all of your inputs and outputs beforehand, and we do that through an abstraction, what we call channels. A channel on the host, on the outside of ZeroVM, can be a file, it can be a pipe, it can be a socket, or whatever. But inside it's just treated as a file. Everything looks like a file. And you can read and write, and you can declare, okay, read only, or read write, or whatever. Like I said, it starts up in 5 milliseconds, no interpretation. The cool thing about it is that this gets really useful when you have an environment where multiple users are running arbitrary code. You don't want them to talk to each other, probably. So the worst thing a user can do with his or her code is to just crash itself. That's it. They can't break out. If you want to read about how that works, there's a thing called suffer fault isolation. That's the core concept in NACL, the native client. You can read about that. This means that you can embed it in data stores like OpenStack Swift. And we've done this today. It works already. We're still developing it to add some more cool features. So the cool thing about this is that you can send code to the data, do computations in place. And you have lots and lots of tiny little processes that live for just a few seconds, and then they're discarded and never reused. If you want to program on this thing, you can write in C or C++. We've also ported CPython 2.7. We're working on Python 3. And we also support Lua for some reason. Why is this interesting to Python people? Well, most of our developer tools are written in Python. Testing tools, and of course the thing that enables this, the glue between Swift and ZeroVM is this ZeroCloud thing, and that's written in Python, of course. Everything is Apache 2. It's all open source, so use it, contribute to it. And if you want to find out more about ZeroVM, check out these websites. Come harass us on IRC, or harass that Twitter handle right there. And that's all. Thank you very much. Oh, and if you
Another just gentle reminder, your phones have other settings than ring. Klaus Bremer, you're up next. All right, I see you.
Okay, so good afternoon, everyone. So my name is Dmitry Generov. I work for Google, and I'm here to talk about zombies and application frameworks. So first of all, why zombies? Let's get this out of the way first. So some guys a few years ago wrote a scientific paper on modeling an outbreak of a zombie infection. And the math involved there involves solving as like a system of differential equations. And the SciPy guys actually made a cookbook sample out of this. And what I did with this was deploy this to Google App Engine. So just to show that it actually works, so here's my little website. I can just change some values, birth rate, press the simulate button, and provided that my network connection is doing fine, it will show me the updated graph. I'm actually using my personal hotspot on the phone. Yep, so it works. But wait, this is an App Engine application. How could I deploy SciPy and matplotlib to App Engine? This doesn't work. Actually, what I used here was a new feature of App Engine, which is called Manage VMs. And here's a link to some documentation of it. And what this allows me to do is to run the App Engine runtime on the standard Google Compute Engine VMs, which means that I still get to use most of the App Engine APIs that are familiar, like the data store, memcache, authentication. And in addition to that, I get to do a lot of stuff that wasn't previously possible, such as running background threads and processes, installing like binary models, which I just did. I can have direct network and disk access, and I can even, with some caveats, direct the SSH into the machine running on the App Engine instance. And I also get the compute engine pricing. So unlike App Engine instances, compute engine VMs do not really start in like milliseconds. They start in minutes. So I actually have a long-running VM, and I have to pay to keep it running. But still, the pricing still is relatively nice. So how can this actually be accomplished? So in my app.yaml file, in addition to the standard like App Engine stuff that I usually have there, I add this key parameter, which is called VM equals VM:true. This means that I want to use this new managed VM stuff. When I do that, I also have to set up to tell which kind of instances I want and how many of them. So in this case, I'm telling that I want manual scaling. I just want one instance. And here I specify the type of the instance that I want to use. So like N1 standard 1 is just some, it has one core, it has some amount of memory, just the default compute engine instance. And this wonderful apt-get install line allows me to actually install binary packages onto my machine as it's installed. And I want to install NumPy, SciPy, and the matplotlib package. Now, once I have done that, I can actually go into the Google Developers Console and check the state of my instance. So so this is my instance. I can see its state, I can see its IP address, and I can even press the SSH button to connect into it. And I think I have an SSH window already open. No, I don't. So let me open this again. And so this connects direct to the machine directly from my browser without any native, without any Chrome apps, without any native code, without any plugins. It's just a complete in-browser implementation of the SSH. And now that I have got there, I can actually, for example, get the list of processes and peek a little bit under the hood. So what's actually running there? Like there is like all kinds of interesting Google stuff running there. And for example, you can see Docker there. And you can see through that my application was actually deployed as a Docker image. So this feature is actually now in limited preview. So if you want to use it for your own stuff, you have to sign up for the limited preview. So here's the link where you can do that. And if you have any more questions on this, then you can find me. I'll be around during the rest of the conference. Thanks, everyone.
Larry Hastings. All right, he would be next.
Wunderbar. Direkt gucken, ob das klappt. Normalerweise geht das von alleine. Great. Yes, my name is Klaus Bremer, and I like to talk about the RVM Fritz box today. The box is a very popular internet access router here, at least in Germany. And what you see here is a picture of an older model, but that doesn't matter. Some time ago, I have tried to access this box by means of Python, but unfortunately, I was not able to find any library that allowed that. And so I decided to write my own one. And I've named it Fritz Connection. And before you can talk to this box, you first have to know how this box talks to you. And this is based on UPnP and WSDL. And by the latter one, which is an XML-based dialect, the box tells you about their own API. And once you know this, you can start to exchange data by means of SOAP via HTTP. And the API itself is organized in services. Every service has a lot of action, and any action may get some parameters and may return a result. That depends on the action. Yes, to work with Fritz Connection, you first have to install it. That goes by pip install Fritz Connection. And then you may have to wait some time because it depends on requests and LXML. And LXML might have to compile, so this can take a few minutes. But afterwards, you are able to inspect the API. This is just a two-liner. You say import Fritz Connection as FC, FC to make a long word short, and then you say fc print API. You get the, you send the address of your Fritzbox, the IP address, but that's not, that's optional because Fritz Connection knows how to find your box. But you may have changed the IP or may have more than one Fritzbox in your network. And then you give your password, and as a result, you get a very, very long list of all available services and corresponding action names, and the parameters for the actions as tuples here. The first item in this tuple is the name of the parameter, the second one, whether it's inbound or outbound, and the last one, the type of the parameter. Once you know this, you can start to use the API. This is done by the method callAction, and callAction needs the service name, the action name, and optional some parameters. And here's a very simple example. You can say callAction one IP connection and force termination as action name. Then the box will reconnect, and you may get a new external IP from your service provider. And because it's hard to remember all the service names and action names, you can wrap it, and here is a shorter call. You can just call fc reconnect, and it's done. There are more complicated examples. For example, this. There's a module named Fritz Host, which lists you all active hosts which are connected to the box. This is a snapshot from my own home office, as you can see. And because this is a lightning talk, I see there is a repository for it, and there are a lot of links there to the documentation of the available service names and action names, and you can have a look at the code. And if you say, well, this code is quite ugly and I can do it better, so please feel free to improve it. In this sense, thank you very much.
Okay, exercise. Pick up your phone. Unlock it. Check the icon that says whether it's on sound, ring, vibrate, or silent. Make sure it's either vibration or silent. We are having currently 1 ring per lightning talk. I think we can get the ratio down a little bit. Thank you.
It doesn't work if this is Apple, then is this an Apple connector?
Yeah.
Okay. I don't see it.
Okay, we can try the VGA one.
Oh, there you go. Hey, it is.
You good?
Yeah. Ready? Okay. Ladies and gentlemen, my name is Larry Hastings. I was the release manager for Python 3.4, and I'm probably going to do it again for 3.5. I'm here to tell you a little bit about how CPython works internally and show you a problem that we were having and how we solved it with a new tool. And by we, I kind of mean me. I did most of this. So let's talk about the problem. Here we have a Python interpreter, and it's running your wonderful code, and you just happen to call os.dupe2, and you pass in 2 handles, which are actually Python integers. So this goes into the CPython interpreter, and it whirls round and around and around. It comes out here. This is POSIX_dupe2. This is a C function that is the implementation of dupe2 for CPython. How does this work? And specifically, how do we turn those Python objects, which are h and h2, these Python integers, how do we turn them into native C integers, which is what the C code really wants to talk to? So here's POSIX_dupe2. This is sort of the external stuff. There's the doc string, which is a C string, and there's the external interface for dupe2. Most of it is kind of interesting. It returns a PyObject star. Everything that is an object in CPython is a PyObject star. It takes in a module, and here it takes the args and kw args. And this is the interesting part, or at least for this talk. Args is a pointer to a tuple, and that contains the positional arguments. Kw args is a pointer to a dict, and that contains the keyword arguments, if there are any. But these are still Python values. How do we turn them into native C values, which is what we want to deal with? This is it. You actually, it's up to you to write this code. And so there's code that looks a lot like this all over the place in CPython. Every time that you want to deal with a parameter, you kind of have to write it in a bunch of different places. So in Python 3.4, we added this new inheritable parameter to dup2, and we had to touch 4 different places. We had to add it to this keywords list so that it knew its name for a keyword parameter. We had to actually declare the variable. We had to tell it what type it was. This little I means it's an integer, and the pipe means it's optional. And this inheritable, that's how it actually writes it in. We actually had to touch 5 different places, but we forgot one. We forgot to touch the docstring. And the reason I point this out is because we're now up to 5 different places you have to touch when you add a new parameter, and it's kind of an error-prone process. So we were talking about adding a 6th one to get introspection information. Right now, if you call inspect.signature on os.dup2, you don't get a signature back. We wanted to fix that, but that would mean adding a 6th place, and now this seemed like it was going to be way too much work. It was going to be way too error-prone to manage all of these things. So I wrote a new tool. It's called Argument Clinic. The way this works is you write a comment inside of your C file. It's literally a C comment with these extra funny strings at the beginning and the end. And inside of that, this is machine-readable information formatted, sort of vaguely Python-esque, kinda. It's not intended to look like Python. It's intended to be convenient for the person who's writing it. So you declare the name of your function, you declare your arguments, and you only have to write them once. Here you're declaring the arguments, you're declaring their default values, you're declaring their C types, and you're declaring per argument docstrings, which is just a convention for encouraging people to document more, really. And then at the bottom, you have the actual docstring for the entire function. This is input to Clinic. Clinic runs over the code, finds this, and then writes immediately afterwards in the C file its output. Its output is C code. This is similar to a tool, by the way, called COG, written by Ned Batchelder, which was a brilliant idea. So this is C code that's dealing with informing Python about dup2. So there's the docstring, and that's actually, by the way, where we hid the introspection information. It's that funny-looking first line. Here is a method def, which is how we tell Python, here's a function called dup2, here's the function you should call when you call it. This is the external implementation of dup2, and Argument Clinic writes that, and that has all of the argument parsing stuff, and it writes a new function for you. You write in the middle, called do2impl, and you'll note FD, FD2, and inheritable, it's done all the conversion for you. It's now in lovely native C types, and your code becomes much cleaner to read inside of CPython. All this upper code, this stuff, is actually hidden in a separate file, so you don't even see it anymore. That's about all I got. If you want to know more about it, you can read the PEP 436, or you can look at the source code. It ships with Python, tools, clinic, clinic.py, and it's only about 4,000 lines. Thanks very much.
The next one after Sebastian will be Stefan Trotter. Are you there? All right, I can see him. Thanks.
No, it seems it's not working. Let's try with B here.
Wait a second. Okay. Let me try again. But he needs time to adjust with A. The external screen activated.
Should be automatic.
It sometimes takes them a little time. All right, you good?
Hi everyone, I'm Sebastian Kreff, and today I'm going to talk about PEP 473, adding structured data to built-in exceptions. It's a draft PEP, so if you like the idea or you have any comments, please contact me. I started thinking about this when I was working on doing TDD on a huge code base, and either because I was lacking some understanding of the code or typos, some tests would fail, and the error messages are not helpful at all. So the worst example is index error. So you don't get back either the offending index nor the size of the container, and it's even worse when you have a nested indexing because you don't even have the offset. And So I started with a really hacky solution. I instrument the bytecode to temporarily store some additional information about the index and the receiving object, and which is open source, by the way. And then I have a test runner that collects all this information and output it like nicely. So in this case, it's kind of like much more direct to see that we have an off by one error. And so we can go and fix the code without having to debug it or like add extra print statements or whatever method you like. And of course, the limitations of this is not portable. It only works with CPython 2 and also relies on the error messages, which are like not standard within the standard library itself. So I decided to reach the community. I wrote to Python Ideas, and they were really supportive, and they point me to some pre-existing issues related to this. Like some of those are like older than 10 years old. And basically this PEP, what it is, it's a summary of all the attempts of like all these people, including Guido, trying to have like more useful exceptions. So for the case of index error, we would like add like the target, the index, which is just an alias of the key, and for example, for value error, we could have like the unexpected value. So then like test runners could like get this information and try to like do some automated debugging for you. The same could be possible in an interactive console like EuroPython, or like for diagnosing failing requests in a web application or long running processes. And in the long term, the idea is like with this information to provide a uniform and normalized error message for all the standard library. So if you find this interesting and want to see it implemented or have any comments, go read the PEP and send me an email.
A small announcement. The local Bitcoin group, they are having their opening ceremony for their new office tonight at 6:30 in their office, obviously. Go to their booth and check out for details if you want to go there. The next after Stefan will be Mark Shannon. Mark, are you around? Excellent.
So, my name is Stefan Trotter. I'm giving a talk on Thursday about supporting Python 2 and 3 with the same code. And I got a few questions on this yesterday, what this is about, and I thought I might say a few words about this, or for whom this is for. The talk is intended for developers maintaining a library for Python 2, and your users asking you all the time, please add Python 3 support. We need Python 3, really, we do. Okay, but you are a bit reluctant maybe and don't know how much work this will be. And of course, there's this variant, you are the user and you're waiting for someone else to port this library or adapt the library for Python 3. The talk is not about all the differences, big and small differences between Python 2 and 3. There are other documents which summarize this quite nicely. One is, of course, what's new in Python 3 or 3.0 actually. And another one is porting to Python 3 or something. Very good guide. The talk is about some differences between Python 2 and 3, mostly related to Python versus bytes versus Unicode issues, because this is, I think, the most complex part, which might require real thought. I mean, which is not so straightforward to get right. I discussed some steps to take to get to a Python 3 version of your library or the Python 2 code, so it runs on both Python 2 and 3 unchanged. And also some API design advice how you can do this, and some other useful tips or best practices. Yeah. I also want to give a sprint or offer a sprint on Saturday at least, and possibly Sunday. I don't know how much of Sunday I will be here still. So if you have a library that you want to port or adapt for Python 3, again, with the same source code for Python 2 and 3, yeah, you're welcome. Yeah. Thanks.
I think my counter ran out of power.
Okay, I have no slides, it doesn't matter. Okay, this talk's called Birthday, and you'll see why in a second. Right, well, EuroPython's really good, and it's even better if it's your birthday. Hands up if it's your birthday this week. Just me? Oh no, I see some other people. Good. In fact, it's my birthday today. This is not just an attempt to get free cake and beer. There is some other logic there. Anyway. Right, well, a birthday is just a number. It's a number between 1 and 366. So it's just an arbitrary function mapping a person to some small number. It's a hash function. It's an 8.5-bit hash function. So, right, who's heard of the birthday paradox? Good number, most of you. Okay, for those who haven't. Hands up again, whose birthday it was this week? No, actually, whose birthday is it today? So, I can't see from here. Go on, somebody must have their hand up. There's got to be like at least 300 people. Okay, well that's good. So that's quite a good hash function. It tends to, not too many collisions. But the problem is, if you take a group of people and say find the probability of more than half of them having the same birthday, you only need 23 people for that to be the case. So that's your birthday paradox, not really a paradox. So you might think you've got quite a good hash function, but chance of collisions is slightly different. In fact, if you've got an n-bit hash function, if you get close to 2 to the n over 2 items, you're likely to have a collision. So if you've got a hash function of 20 bits, which gives you 1 million items, if you have 1,000 entries, good chance you'll have a collision. A whole number of percent. Okay. So hash functions are useful for chopping stuff up into data, but they're sort of probabilistic. So who's heard of Bloom filters? I'm not preaching to the converter too much, but definitely a fair bit. Okay, so it's a probabilistic set. It's a way of using a hash function to say, is this a member of some set? And what it gives us a nice property that we never get any false negatives, but we might have false positives. So if we're going to do a Bloom filter based on using birthdays as a hash, we'd use 366 bits. But let's suppose we haven't got a big, expensive server that has 366 bits of memory. Suppose we've got this little laptop with 43 bits of memory. So what we can do is we can break the hash up into different hashes, smaller hashes, and save a bit of memory there. By the way, if anyone actually does know how Bloom filters work, they're probably wincing, and I suggest you go and look at Wikipedia afterwards. But this is kind of fun introduction. So I need 2 volunteers from the front row. Come on, don't be shy. It's 1. Go on, I had to stand up here. All you have to do is put your hand up. Okay, we've got 2 people, right. Can I have your name? You are? J-O-A-R. Which is pronounced? You are. And the day of your birth? 24th. And the month? 10. And sorry, there's a gentleman over there. Peter? Dimitri. I can't hear very well up here, obviously. Dimitri, and 24th. This is not working well, of October. And yours was? Okay. Okay. Probabilistic data structures for you. Can I have another volunteer just to make this thing work a little bit better? Another volunteer, please. Okay, sorry. Yes, please. Luis. And hopefully you're not born on 24th of October. 12th of December. Was that, sorry? 12/12. Okay. So, we have our Bloom filter, and we're looking for or Louis. Louis, sorry, not Dimitri, because we've just scratched Dimitri because he had the wrong birthday. So we have our Bloom filter, and basically what we want to do is we can say probabilistically somebody's probably either you are or Lewis. We can't say for sure that they are, but we can say they're surely if they're not. So I want everyone in the front. If you can see the microphone without turning your head, you're at the front. If you can see a microphone, you're at the back. I want everyone at the front to raise your left hand if your date of birth was the 24th or the 12th. Go on, don't be shy. This doesn't work if you're shy. Really? There's like 2 or 3 people there.
You're out of time, actually.
Oh, well.
Thomas Weidmann, du bist dran. Thomas.
Ja, fix. Bei mir ist der Strom ausgegangen. Ah ja, okay. Lass dich nicht irritieren, ich muss bloß meinen Account immer. Ja. Okay. I just wanted to show you 2 rather new projects. The one is nsupdate.info and the other is ePasty. And the special thing is both were initially written in 48 hours. It was a contest and it happened at a Stuttgart hackerspace called Checkspace. And I start with nsupdate.info. You maybe have used a dynamic DNS service like NoIP or DynDNS or some of the others, but usually they want to sell you something and only some features are for free and other features are for pay. And also it's sometimes a bit difficult to find the free features because they have lots of features. And we just thought we write a new one that's much simpler. On this new service, it's made with Django, by the way. You can have one account, but you can have many hosts, so you don't need to create a new account for every host. It helps you configure your router. You even have a small browser-based update client if you have no other update client. This is for ad hoc usage. You can update hosts in your own domain if you run your own name server. And you can even update other services that are based on the dynamic DNS protocol. And it supports IPv6 also, and it uses SSL, of course. So it's on GitHub. nsupdate-info is the organization. It's BSD licensed, Python, Django, Bootstrap, jQuery, and a library called DNSPython that does all the low-level DNS stuff. You can run your own instance on your own server. You need the software, a web server, Whiskey, a name server, and a database server. But you can even use SQLite 3, so no big database needed. I maybe show shortly a few pictures. Looks like this. If you are not logged in, it shows your IP. If you have IPv6 connectivity, also shows the IPv6 address. This is the login screen. You have a local account, or you can also log in with GitHub or Bitbucket or Google. This is if you have created a few hosts. On the left, you can create a new host. It's just typing in some name, selecting a domain. It also shows your reverse DNS. This happens after you created a host. It shows you're ready to use dd client conf. You just copy and paste this piece of text into the config and it immediately works. So creating a new host is about 2 minutes maybe. This is the screen if you edit a host. You can change the IP and so on. And you can add new domains if you control a domain name server. And if you add a new domain, it even shows you your bind9 config. If you copy and paste this to your bind installation, it also will immediately work and accept updates. statistics, and there is even documentation. It's on GitHub, have a look. The other project is Pastebin. Oops, yeah, fuck. There are lots of pastebins. Usually you just paste text into them. We wanted to create a new one that accepts every content type. So you can paste PDFs or upload PDFs. You can upload images, video, audio, binaries. If it's text, you get highlighting as usual. If it's other content, you get just the appropriate rendering if possible. You can drag and drop multiple files. If you have a modern browser, you get file lists if you drag and drop multiple stuff. There's a simple permission system in it, and it can even deal with large files efficiently. It's also on GitHub. It's called bpasty. It's BSD license, Python, Flask, Bootstrap, jQuery, and so on. And in general, we need your help. If such a project is interesting for you, it's good for newbies also. It's rather small projects. Just join us, contribute your ideas, bug fixes, security reviews. You find me on Twitter, and I'm also here for the sprints. Okay, thank you.
Christian Heimes, are you around? All right, excellent. And after Christian, there's going to be Rock. Rock, did I see you? All right, excellent.
Oh, sorry. Ich habe gerade mal so mein Display entsperren. Okay. So. Ah. Oh, this is display configuration. I think I need the other display. Oh, no. Doesn't start. Oh, it starts on the wrong display. I have this problem. Okay, let's try it this way. Doesn't switch over.
Want to start?
Okay. So, hi, I'm Christian Heimes. I'm a professional paranoid Python core committer. I'm one of the guys that takes care of the security of CPython. So, if you want to know more, you can reach me on Twitter or on email. So, I'd like to talk to you what we'll actually do at the... today I'd like to talk to you what we actually do with CPython core security. We have a Python security response team. That's a team that interacts with all incoming bug reports. We work rather closely with Red Hat and Google, and also with core developers from other teams. For example, at one time we had an issue that was first detected by Ruby guys, and later I ported the security fix for Python to PHP. So we were able to fix the issue on all 3 projects. Also, we are using a tool called KuberneteScan. It's a commercial tool, but free for open source. It's a static C code analyzer. With this URL, you can find CPython. Kubernetes defined this limits defect density for different kinds of projects in size. So for Python, it would be about 0.5. But actually today it's... So we just have 2 outstanding issues because I updated the tool chain to a new version and detected 2 more issues. I hope to close that in a couple of days. So we got some new things. I implemented this PEP. It replaces the old hash function used for dictionaries. And so the thing that hashes the strings and Unicode strings to a hash.
with ziphash 24 from DJ Bernstein. Another guy implemented this PEP. It's basically, it ensures that file descriptors doesn't get leaked to sub-processes. It's especially important if you have a root daemon that starts some other processes that are that should not get sensitive informations. That's the isolated mode, a new feature too, that does something so console script doesn't get poisoned by the user side directory or some envars. OSURandom got a bit optimized for Python 3.4. It uses a persistent file descriptor. Eventually, we're going to use the new shiny getRandom syscall Linux getting these days. On Windows, we're using this function. Oh, and by the way, if you're using, you want to have any random secure random numbers, don't ever use the random module. It's uses a Mazzano twister, and if an attacker is able to get this amount of outputs, it can guess any future outputs. It's 624, so not much. This is another feature I implemented for Python 3.4. It's a password-based key derivation function too. While I was implementing this, I found a DOS vulnerability in OpenSSL in their implementation. By the way, the same issue Django had a while ago. So, and if you're dealing with passwords, never ever use anything else than these three functions. bcrypt and scrypt are fine too. If you need this function in Python 2 or other versions, please use my library, because it's much, much faster than any other libraries currently on the market. So, there's also some changes in the HMAC module. With Python 3.3, we already had this compute digest comparison function. Python 3.4, we're getting another one. And the good thing is, we're almost out of time. So skipping to the end, several of these features will be backported to Python 2.7. So really new features, except for security.
After Rock, the last slot will be for, that's one name I really don't know how to pronounce. Joar, exactly. You're next.
Should be not there. It's okay. Okay. Yeah, it's gonna work. Cool. Hi guys, I'm Rock. I work for Roadcode. And as any of you, I install my software, and as a developer, I install it even more often. I have multiple versions, different project, different platform, not only Python. Therefore, I usually broke my system. Not anymore, since I switched to Nix. Nix is a package manager. You heard the talk this morning from my friend Dolman about it, the internals. I would just like to go through all the features it offers and invite you at the end of the EuroPython to join us to sprint and make sure you don't break your system by just developing on your project. So Nix, let's start in the top bottom. It's portable. It works on any POSIX platform, which means poor macOS users could actually now go away from Homebrew, because we ship also binaries. So yeah, we have a transparent source binary model. So if the binaries are not found, yes, we'll compile them for you if it's needed. We support multi-user and multi-version solution to the problem. So you can have different Python versions installed at the same time in the same environment, and they do not conflict. Going up, we make sure that every installation you do, it's reliable and it doesn't break anything outside of that installation.
even sometimes happen that some installation break, all the installations are atomic. If something goes wrong, either the installation is installed, application is installed successfully, you can always roll back to previous version. It's reproducible. The thing that bugs me the most is when somebody does a false release on PyPy, and somebody forgot to pin the versions that I'm developing. At one point, I end up with a broken development environment. We make sure here by default, you get it's always working once you set it up. And well, all in all, Nix is great for developers. Think of Nix as a virtual env, the tool you probably are all using, but much bigger. It's not only meant for Python. You use it for any project, any language-specific project you have. You can even bind them more together, because I think nowadays we are all kind of forced, at least, to learn JavaScript and all the tool stack they have. So it's one tool to do the job. And just to maybe, because you're probably wondering, yeah, this is a tool that looks, again, like Docker, right? We don't virtualize anything. We think a packaging problem should be done on the packaging level. We can output, we can provision, or whatever you want to call it, Docker, VirtualBox, any images, but you can just use it for bootstrapping your development environment and not screwing up your laptop. Thank you, and hope to see you on Saturday. We'll have a Nix Corner, and we can get you up and running for basically any development environment you need. Thank you.
SER will be the last one, and as we have been talking about sprints a couple of times already, who of you is thinking about joining us on the sprints on Saturday? Can you show me your hands? That is a good number. That is awesome. It looks like, I would guess, at least 50, 60 in here. That's very nice.
All right, my name is UR, and I came to a realization yesterday that setup Pi, the dependency declaration for your program basically, is Turing complete. So I exploited that fact, and I created a package called deproulette. You never know what you get. So pip install deproulette, and then don't do it. Just don't. That's all. Thank you very much.
That was fast. You've got the shortest lightning talk. Awesome. It's 45 seconds.